When does a series converge? Give the A values for which this series converges. Well, I would just start right off with the ratio test, which says that the series will converge if the limit as k approaches infinity of the n plus 1th term, so k plus 1, divided by the nth term, so we'll multiply by the reciprocal of that, is less than 1. We'll rewrite it by using the commutative power of multiplication. And now as k approaches infinity, this approaches 1. Which brings us here. The series converges when this is true. As k approaches infinity, these little plus 4s become meaningless and insignificant, so we can reduce it to this. Now what? Well, this actually approaches 1, which is not less than 1, so the ratio test is inconclusive. We'll have to try something else. Let this be a lesson to you. If your series expression looks like it's just a rational expression, a fraction, and if the variable is the exact same variable in the top and the bottom, you should immediately just be thinking of comparing it to a p-series. Well, the p-series will only converge if this exponent is bigger than 1, and diverges if the p-value is between 0 and 1, including 1. So they're asking us for what a values does this series converge. So we're going to compare it to a converging p-series, and this p-series will only converge if this exponent is bigger than 1. So that's pretty much it. A will have to be bigger than 3. We can go ahead and do the limit comparison test with this series and the converging p-series. It'll pass, and both series will converge, and it will only be when a is bigger than 3. Now that wasn't one of the answer choices, but if you look at the answer key, that is the answer that the answer key has. Your answer choices just was flawed. There should have been an option where a is bigger than 3.